Okay, we're going to revisit the crank assembly. Uh, this has some interesting geometry and have to do a little research, and we'll add a few more GD&T stack up of tolerances things to it. So looking at this assembly, we have the mount, and first thing to notice is that we have symmetry, so I could draw half of this and mirror it over, or depending on what we want to do with the geometry, the center line, and looking further down downstream, the sizing, the clearance holes, and what kind of stack up of tolerances and GD&T we can use to build, and also go out to McMaster and see about what currently available bearing, standard or metric bearing is available, and build closer to it. On the handle, radius, keyway, 3/16 is going to be the long side. The 1/8 inch will be the front, top to bottom on the regular key. So we'll have a little bit more engagement. 3/32, 0.94, not quite 2.5 millimeters of engagement on both sides. So we'll take a look at keyways. The interesting one is the SAE Series B spline shaft. I can't say that I'm fond of that. Depending on what we decide to drive with and why we would need to drive with that. Putting in flats and set screws may do the same thing for a light duty application, but we'll go ahead and draw that geometry. And this kind of tapers off, so that would tell me that we're expecting this to be kind of like a Woodruff key, or have the profile of a ground tool to go in and make that geometry and have it taper off. We're not given a full depth, so the 0.562 is the inside diameter. 375, that certainly doesn't look long enough to be the 375, so I'm not finding that number anywhere in the chart. So when we get to that, we'll have to visit that a little bit more. Let's see, wrong way. We have the knob, and that's going to go in with the keyway. And again, we don't really have anything retaining this. And the stack up of geometry, let's see, they did put a 1/4-20 here on the other side. So 3/8, 16, and 1/4-20 to drive those in. And the main issue is going to be that as you're turning this, you're either loosening or tightening it. So we would probably still need some kind of pin or keyway to lock those together. So let's get started with our mount, and we'll see what we can generate. So this is in inches. So the I'm always surprised after going metric almost all the way through. We pop up with one that's inches. So make sure you're in inch, pounds, and seconds. Front plane, we're going to, let's just go into center line. Anytime I'm doing a mirror or revolve, we're going to put in that infinite length center line. And one of the things that I still like to do is just create the envelope. Okay, so if I go and make that line the midpoint, also notice that I am getting the preview pop up. So in 2024, they added, and I want to make sure to see this again. under the sketch, preview sketch dimensions was selected. I saw this last week and have pretty much adopted it as my new favorite tool. All right, so what it's doing is when we click on a object, that we'll be able to pick that dimension if we want, and we would set the overall. Well, that's not really, well, I can do the math. 2.5 and 2.5 is 5, and 3 would be 8. So let's put that in there to size it, and then I can always turn it into something that's driven later. All right, so if I draw those and do the select control select of my objects, or window pick right to, oh, I'm in the, that is one downside to the shaded sketch contours. It doesn't like to pick in the, the shading. So we want to mirror those entities, and then I can turn it back on. So 1.5 off of the side, and I expect this to give me some error if I build it up even further. So if I put in the 2.5, I have to decide, do I want to make this dimension driven or leave it driving? If I leave it driving, then I'm going to see these errors. So that would be a point where I would go back to the overall, make it driven, and then I could check that geometry. So different ways of managing your sketch. We have the 1 inch, and then pretty much same thing on the bottom for the relief. Let's just go ahead and carry that across. If I do that, stop that line at the center line, then I'm going to get the star, the asterisk for the symmetry, which doesn't hurt anything, but in this case it's not really helping. So we'll go ahead and add those two. We're not given a depth, or at least it doesn't appear that I'm seeing the depth. So since the fillets and rounds are 250, I'm going to take a guess that that is going to be either 1/2 inch or 375. All right, so that looks pretty thin through that cross section, but shouldn't be generating too much of stress risers with that. All right, so if we go to the through, I can put in the 0.75, and under standard tolerances, we have 250 off of the base. Okay, let's try 2 inch 50. So the center and the shaft, that is something that we would look at tolerancing. So anytime I want to call something out, and especially since I am in my options very early on, I told it to not mark everything as for drawing, or mark all of the dimensions for drawing. So let's expand those out. And if I mark that one for drawing, it will turn black. And then if I do the insert, it will bring in that that dimension by itself. If we insert all dimensions, it's pretty much the same as having everything marked for the drawing. All right, so I want to pay attention to that one. We're going to go ahead and extrude. When I pick my region, center line's there. And we're going to go for a depth of 2 inches. Let's see what I want that to be on the center line, or the mid plane, or back to facing back. Yeah, that looks okay. So we'll go with that one. And going to our next geometry, I can pick up bore. Now this one's going to be tolerance. There's no way that we're going to slide a bearing in there and not have it flop around if we stay with the 2-place decimal. We're going to have to tolerance that a little bit better. So on this one, we'll go in and do the extrude cut, 0.69. All right, so if we go to the actual fraction, then we would have 11/16, we'd be at 0.6875. Probably not critical there. And since I am freely modifying this based on my experience, I'm also going to put a relief in for the center for the race of the bearing. So what I like to do is find some geometry that will be a little bit bigger than that center section, just so it doesn't rub. And it only has to be maybe 20 thousandths deep to provide clearance, right? Something that would drag on the bearing and reduce its operational life. So let's go into the sketch. Oh, these could be what do we have here? I'm not seeing a dimension for those. Let's pull this back over. Got the 1 inch in, 1 inch from the side. So since I'm in sketch mode and don't think I'm ever going to switch this over to a countersink or a counter bore, as soon as I think I'm not going to do that, I'm probably going to do that. Let's discard that, and we'll go back in to the hole wizard. And even though it's a through hole, I'm going to do an inch and screw clearances, and we're going to say that that is 3/8 of an inch. All right, so 3/8 16 or 3/8 24. And up to next, we have close fit. It depends on, originally would think that maybe this is a casting. If not, then machining this out with our geometries. Yeah, it would probably still stay on the close size. General rule being that if this is a prototype, we can always make it larger. It's not as easy to make it smaller. All right, so let's go ahead and put that in place and see what it looks like. So let's just center line. So this is one of the advantages that I could have had if I put it on the mid plane, is I could have just made this horizontal to the origin. All right, so making those two, dragging and dropping those two center points onto the center line, and then dimensioning. I could put in the other center line. The only thing here that would be of concern with the 1 inch is that if I didn't make these symmetrical and this changed, I would have to decide which is more important, the center distance based on my bearing geometry, that if I had to grow this or shrink this, is the other component going to be able to grow and shrink with it? So that being the case, let's think through this process, and I will go ahead and put the center line in then and make those symmetric. Pick one more and go symmetry. All right, so I expect that to be an error. So if I make one of those driven, then we'll have the geometry. If I go to my preview, and is a driven dimensions, its value cannot be changed. All right, so even though it shows me the preview, it's not going to let me change that one, and probably did not put it into the mix. All right, so not seeing those dimensions. All right, so all fillets and rounds are 1/4 of an inch. And I don't really want to select all of those. So just going through and picking is going to work out okay. So that gives me my geometry from a manufacturing standpoint, I'm pretty good with all of this. Putting in the 1/4 inch. If I could make those a little bit bigger, I would. Going in and cutting those out, and just thinking about the machining process, that's pretty long length for a 1/4 inch. So bigger the external rounds as opposed to the internal fillets. This side, I could see pocketing this out and just taking a 1/2 inch ball end mill and doing that relief. All right, so let's go ahead and start setting up for our custom properties. If you have not created custom properties, then you're going to go to File Properties or to File, and I know you're here somewhere, Properties, and we'll add those items like a part number. If we want the description, usually with the description, I make the part name, and then we need to pick the material. So those things would get added as you go. If you've watched the custom properties and set those up, you can kind of pick the ones that are appropriate for your title block. So part number is going to be EX131-1, and revision A, material is steel, so probably a 1020 1018, and this one is in pounds, but it is going to be dependent on what we've set our template to. So we'll set the model by and date because that picks up in my drawing template. So we'll go to the drive, find my part since I have not created my final project. Go and name something that makes sense, and then this will be the support. Okay, so the next, let's go with well, I guess I should go back and look what they called that. All right, so the link is number 2, and then the shaft drive is number 3. So we'll kind of go and follow that order. All right, so looking at our geometry then, it'll let me exit out of that. All right, so the 0.75, whenever I see these, I just think the odd brown works pretty good. The 3/16 dimension and the rectangular key. Let's see, 0.75. The end of the shaft that's going to go in there is going to be the 3/4, so that should work out okay. So new part inch, we'll go into the front plane, pick, let's go with the center point, and we can go ahead and dimension those. 0.75 on both ends, and then 4.5 between the centers. Let's see, 1/4 so we'll probably want to do that with the hole wizard. Setting the shaft, I don't know that it'll much matter. Let's go ahead and extrude this out though, 0.25, and we'll use that sketch. So we'll go ahead, I can pick up the center on that one. So I was going to say the endpoint would be a good mix, but if I drag along that edge, it's going to show me the center point anyway. All right, so this is another stack up of tolerance that I am going to want to pay attention to. So I'm going to go ahead and mark it for the drawing. And I've been doing that so long that I think if I slow down and look up here, one of those, no. Oh, and then there's another preview sketch dimensions. So that's a little easier to turn it off and turn it on than going into the options. So another one, good to know. Let's go with the 3/16. So if I select the midpoint, and easiest way to draw these keyways, let's see, did I get the horizontal in there? So yes, that one is going to be 0.1875, and keyways, the 0.19 is probably fine on that geometry, and 0.125 on the width. We do want the width to be a little on the snug side. You don't want that keyway to be able to roll over. And then we're going to go to the midpoint and make it coincident with the circle. Oh, so I didn't apply that. All right, so let's try that again. 0.125 and enter. And then we're going to cut that with our geometry through all. And when I select the contours, I can do regions, or I can do the contours or a mix. All right, so we'll come over and the whole wizard, pick our threaded, find the 1/4 and it's going to be up to next. Drag along that edge and just go to the center. Okay, so we'll save that as the link. Okay, and then we'll go to the shaft. So we know that the shaft has that that spline on it, and so I would like to maybe explore a configuration that allows me to go into that geometry. Oh, and I forgot the part numbers for that. So even though it's not 100% critical to put those in right away, well, I'm already into the sketch. So let's go 0.75. If I think about it, that's the time that I'm going to do it. So let's go ahead and extrude that out. Is it going to help to make this mid-plane, or have it come out to the front or to the back? So I can go ahead and save that as the shaft. I'm not real fond of commas in the file names for the description. That's fine. I mean, if we were searching for it, let's go to the R for the recent, and I'll go back into my custom properties, EX131-2. Vision A, materials still is steel. We'll stay with the pounds. And I want to say that depending on the units of the drawing, I made that a higher priority for these guys. All right, so on this end, one of the issues that that usually comes up is how we're going to machine this. So if you have a key slot cutter, you'd come in from the side, and the swoop would come out the back. With the CNC machines and the other geometries that we can, or practices and geometry that we can create, even with the spline, I'm still kind of leaning towards doing this with an end mill. So we're going to put in the 0.75 if I can get it placed. Okay, so not sure why it wouldn't let me have that. Oh, because I'm in the sketch. All right, so let's go with a another corner rectangle. We'll put that one up top. I was thinking I was still creating the sketch. So let's go midpoint, back to the origin, make that vertical. The length is going to be 3/16 again, 0.1875. And the width, 0.125. So it's not a requirement that I use the preview, but if I see those pop up, then yeah, I'm probably going to use them. All right, so the midpoint goes to, and that just centers on our geometry. So when I go to the depth, that's going to give me a good base to work from. All right, so that doesn't again really tell me how deep it goes, since it's lining up with that 1/4 inch. We would probably want to go at least 1/4 of an inch. And then they're also putting chamfers on those. The chamfer looks like maybe a 1/16, and since it's not called out, it's my choice. So I'm going to do the extrude cut, and we'll go a blind in condition of about 375. All right, so here's another one of those. We're assuming that this is going to be a press fit because it's not reduced in size to fill the geometry. It also, going with this process, is easier if I did decide to go back and put that step in for it to not have to perfectly press onto the link. I could also tap the end and give it some compression so that it holds the part in place. All right, so 375 is good. The in-mill portion of this is going to be to open up that sketch, and we'll just go ahead and find a circle, go to the midpoint. That didn't let me go coincident with that point, so we'll add that. And then the features, extrude cut, make sure we're going the right way. And we can just do a through all or up to next. So what that's going to allow is me to take an 1/8 inch end mill, which is probably going to cut just a little bit undersize, and go in and machine out that slot. All right, the other end, the side. So I did a search, and on the American Machine Tools Machinist Tables website, they have this chart, and the W and the D are the items that we're concerned with. So the D portion is the 750. The 562 is the minor diameter, and the 375. I'm not sure what that call out. We'll have to check on our measurement what we get. And going across for the 3/4 inch shaft. The 562, those show up. The sliding fit, yeah, the 375 just doesn't show up. So I'm not seeing that in the geometry. So let's go ahead and open up the sketch. We can try to make it 375 deep, but as I said, I think that looks like it's probably about 1 inch, at least 3/4 of an inch deep. And since it's not specifically called out, there again, we have to get a hold of the mating geometry and find out. So I'm going to convert that outside edge, and we'll bring in some geometry. All right, so the other question, no, those are vertical. So let's go with the preview and 0.562. And if I go vertical, and that did not pick tangent, so that was good. Then we can mirror those entities, and my number from the chart is 181. Okay, so if I take those two lines and create a circular sketch, we have the equal spacing. I don't think the dimension radius based on what I've already created is going to help me, so let's go ahead and do that, and then I'll drag one away. Now this is one of those cases that center point would be my my focus if I see it right away. Most of the time, I just drag one of the objects back and make it coincident. But if we grab that point and put it on the origin, that will do the same thing. I will always go back to the warning though that if you're doing the whole wizard in an older version, the newer versions, I haven't seen that those linear and those circular patterns put in that center point, but it can produce a second instance of your or an additional instance of your hole count. So extrude cut, we're going to pick the regions to remove. Usually there was in a couple of the charts there was a detail about the having some kind of root. So with that curvature and that geometry, though, this is either a custom ground tool or something's being generated there. So I'm not going to worry too much about putting that in. We could always just call the radiuses, but if I needed that geometry, and this is where I probably should have made a better choice, is that if I wanted to make that swoop and have it come out of a custom ground tool to show pretty much the taper of the fade into the back, I should have put one of these off at 45 degrees. But if I go into the top plane or the right plane and go to a reference plane or plane geometry, we can go 45 degrees. And it's asking me for a second reference, so we're going to turn on the temporary axes so that I can find that cylinder. Could probably just use the cylinder itself, but the axes, temporary axes, is a good way to go. All right, so this is probably, okay, this is more complicated than it needs to be, but again, it's more of a how you would do it, not so much that you have to do it. All right, so I don't really want to sweep this, so I'm going to convert the silhouette edge. We're just going to make that part of the sketch, though, as a construction geometry. And on the, let's just go with a tangent arc. And I want to calculate this out as a center. So probably going to have at least a 1-inch tool. Let's go 875. And if I look back towards the silhouette edge, I can probably pick that out and just make it coincident rather than adding more of the geometry. All right, so what did that do? I have something now that I can, I was going to say do a revolve with, but I think I'm still going to have to do the sweep. So we have a path, we need a profile, so let's go ahead and open up the sketch, convert the entities, accept, and then those two don't need to see the plane anymore, so let's hide the plane. And then those two should swept cut, remove that geometry, and give me that little taper edge. All right, so one of the advantages of using that original geometry of the center line would have been maybe I wouldn't see those tangencies, but it's not that big of a deal. So circular pattern. And around the cylinder, no, we do not need 6, we want 4. And that gives us the shape. Probably could have put the chamfers in first as well, but let's just see what it does. All right, so there was also a chamfer selection that was added. Oh, it did find all of them still. Oh, that's pretty good. And 100 thousandths is probably too big, so 0.06. Nope, it didn't give me everything anyway. Oh, there's the selection for the chamfers. I think that was what was added. So interiors, no. Exteriors. Okay, I think we can go with that one, and it also found that one. So, all right, we'll go ahead and save that, and as the drive, the shaft. All right, so let's pull this back in. All right, so that leaves, what are we looking at here? The post threaded, and there again, did I get my my part numbers in? Most of the time, I'll wait until the assembly because I have this difficulty of remembering to put those in. But let's keep going with the 3 revision A. We'll stay with the 1020. Yes, go ahead and save. Do the list. Add a date. All right, one more save to make sure that it gets in there, and then we'll go to the threaded post. All right, so 3 inches with the shaft on either end. There's no reliefs. All right, so if we want these to sit flush, there really needs to be a relief in there. The quarter 20 would 20 is going to give us 50 thousandths pitch, so we'd want to have probably 50 thousandths or so for that clearance, and then make sure that the geometry for the 3/8 16 at least 60, almost 70 thousandths on the clearance. So I'm going to add those in to include for the reliefs. If I do this as a revolve, I can get it in one shot. Otherwise, we would extrude and then build up the geometry again. So new inch, front plane sketch, center line. Let's go horizontal infinite length. Place that on the origin, and to me, it's always easier just to select rather than to try and back out of that, because I usually just end up with a lot of center lines. All right, so there's my geometry, 3 inches, and I'm already in the dimensioning, so I'm just going to stay on with that, 0.38. I guess it would help to place it. And then we had the 0.25 because it's going to intersect the plate. And then we need to go 0.25 on the geometry, 0.75. That seems like quite a bit for what this is doing, but we'll go with the we got to go to the 375 for the major diameter. All right, so for my reliefs, I can add those at any time, but it's going to switch it over to contours and regions. So even the revolves will use that as our geometry. All right, so I would want to calculate my thread depth for these, but I want at least one thread to disappear, 0.62, so I'm going to round up and give it 70 thousandths. And then the thread depth we can verify, but I'm gonna go with an maybe not a 500 thousandths, how about 50 thousandths? And then same thing here. 0.05, let's go up to 0.06 to give it just a little extra. That's not a whole lot, but then 0.03 on the depth. All right, so when I go to revolve this, we can do the contour, and it goes 360 degrees. And no chamfers at the end that we can see, but we will want to have that for our threading as well. All right, so if you've made the thread, and that one's vertical, so I did not make the horizontal, but I don't really want to do that right now. Let's put that on the front plane, and if I edit that sketch, then let's go ahead and finish it. And I'm not going to sweep this or anything, I'm just looking for a pitch. So 0.0625 for the 16th, and then I can grab that dimension, which was 041. All right, so went a little deeper here than we needed, and I do want to utilize that or remember it. So under the tools and the sketch tools, we can, am I still in the sketch? No. Was looking for make sure it didn't hide somewhere on me. All right, so maybe because it's in the pattern. No, there it is. I didn't go far enough down. Let's go modify, and I want to rotate this sketch 90 degrees, and we'll see what it does. Nope. So the problem with rotating this out of the sketch, center of rotation, is I think I'm going to still end up losing some of those dimensions. No, not too bad. All right, well, we'll go with that since the modify, I think maybe because it was, it's still in the library feature. So let's make, yep, I lost some of my relations. So let's see if it'll back up for me now. So if I can correct it, we have the symmetry, but I've lost the verticals. Let's see what we have in the undo. Sketch dimension. Doesn't look like it's going to let me have that one back. Oh, it did. All right. So if I need to, I'm still kind of leaning towards that library features the issue. So I'm going to go back into my modify, sketch tools, and it stayed location-wise 90 degree, and enter. Okay, I don't think I hit enter last time. Now when I edit this, it rotates up. Everything's moving sort of like I expected it. So let's go collinear. And I'm going to go ahead and set this up as if I'm doing the sweep, even if I don't need to do the sweep. All right, so why didn't I go fully defined on that one? So it seems like I still lost something on the, oh, I lost the angle. Don't think I deleted that, but we'll take it. All right, so we said 041 or 051 on that depth. Make sure that it didn't I didn't modify something. I went back to the 0.08 inch, 0625. Highlight that 041. All right, so my depth then on the revolve 050s. I'm gonna stay with that. That was an okay guess. All right, we're going to try that one more time. In fact, I think I will probably just Control C, pick the front plane, see if we can do a Control V for sketch 12. And if I edit sketch 12, let's see if we kept everything or lost. Looks like it kept everything. Nope, got a dimension. So it is going to be one of the drawbacks is left click, hold down, use the scroll wheel, get it a little closer. It picked coincident to something, so I'll take it. Nope, I don't want that one. And we'll go ahead and make that endpoint collinear. Advantage is that it just a fully defined sketch has less issues. So 029.7 on my actual thread depth, so 030 would be fine. All right, so my guesses weren't too far off, and I can hide those to clean up. All right, so I've kind of run that as far as I can. Let's go ahead with the cosmetic thread. Again, insert, annotations, cosmetic thread. If you haven't set those, probably the easier is go to the commands, start typing cosmetic, and that'll take you to the cosmetic thread. If you haven't added, left click, drag it into the features or into the sketch, wherever you can find it. And this is going to be an ANSI inch. It recognizes the quarter 20. Again, I'm not fond of the show type because it puts a note for the machine thread. I would rather just use the dimension and have it pick up my geometry. So diameter, not sure why it went to the 190. We would, okay, yeah, that sort of makes sense, but on the actual thread depth. So cosmetic thread 3/816 up to next 305. All right, so and the last one will be the chamfer. All right, so I made my changes. If you want to put those in, that's going to be fine. I think the 060 is going to be probably too big for the quarter 20, but yeah. So the thread should pretty much wipe those out, but we would want to check that as we cut. All right, so that should be all of the parts, and we'll do the assembly, the drawing, and the first pass of the drawing, so that I forgot the knob. So one more, and we did this. I collapsed my. Let's cancel that because I did not do these guys again. EX 131-5. And this is the post-threaded steel. And we look at some of these weights. This is going to be a heavy assembly. All right, so go ahead and apply, and make sure that we save. Post threaded. Okay, so this one's going to have the thread. And again, the issue here is going to be more if we manufacture this guy and the 3/816 half-inch deep, that as we're turning this, if we're turning it clockwise, we're loosening the knob, and if we're turning it counterclockwise, then we're tightening it. So we just have to kind of be aware of that. All right, so since I collapsed my command manager, this is a good as place as any to say if you haven't started using the S key, go ahead and take a look at the S key. All right, so did not add anything here, but we can customize that. But front plane, sketch, if I go into the S key, I'm going to have those commands based on the way this is drawn. I'm going to go infinite length horizontal. We'll go ahead with the line from the origin. And then I think I want to do the center point arc so that I can go from there to there. And then we just need a dimension. I do want to see what the preview looks like. Yeah, found the preview for it. So take it, diameter of 150 gives me a radius of 0.75. And the center is going to go 0.63. And last one, I can just do L on the keyboard. And then we'll revolve it. Oh, and the revolve is on the S key. I just got ahead of myself. So S key, let's see, there's the whole wizard. And we're going to pick the 3/8-16. And blind in condition, a little bit deeper than what they called out. I'm going to say the deeper is probably better. So we'll go with that geometry and call it good. And then let's close this up, and I need, oh, no, we don't want to keep going back to that one. Let's get that in place. And so the ball bearing, the rectangular key, so they're just going to call it the ball. And save, and then this is going to be EXE 131. I think that's what I called the last one. -5, so I will have to check in my bill of materials what I created. And we'll stay with the steel. Mass units are pounds. And we'll put a date on it so that carries over. All right, one more save, and now that's all of the parts.